Okay, sorry. So apparently I can only make 10-minute videos. So, and you're going to see me trying to rush through this. So we were finishing up with this one. Answer 3 has the largest particles in the beginning right there. So that would be where deposition would take place, largest in the beginning and smallest out farther. 16. Okay, so we got a boulder. That's the only thing I can move a boulder. Ice, large pieces of ice, not a volcano, not a slow moving stream by any means, definitely not a slow moving stream. What must be the size of a boulder? Oh, there's my son. Hi. Amy's helping me. Okay, so boulder, we can figure out the definition of a boulder by looking at the reference table. And don't forget up here, we see boulders that are greater than 25.6 centimeters. So that's what we'd be looking for, 25.6. Oop, wrong, that one. 18. Okay, what characteristic of an erosional depositional interface in a stream where equilibrium occurs? Equilibrium, that would mean deposition equals the rate of erosion. So that'd be number 2. So you're always going to see where I'm like touching the screen. You leaving? Going to bed? Okay, son's going to bed. If the particles below have the same mass and density, which particle will settle the fastest? Size, shape, and density. The roundest shape would settle first. So that'd be answer 1. A glacial deposit would most likely consist of, all right, glaciers. Remember, they're carrying everything at once. They're not discriminating due to size or shape or anything like that. So it would be particles with a wide range of sizes. Anything layered, okay, is going to have to do with running water. Please remember that for Friday. It's definitely a question there. This question, simple. Which feature currently found in the region was a result of glacier? What's your big thing for glacier? I tell you all the time, please make sure you know this. U-shaped valleys for glacier. 22. According to the graph of the relationship particle, okay, so that's the reference table. How fast would a stream have to move in order to move a pebble that is 1 centimeter in diameter? And you look at 1 centimeter and you go across and then you come down, and that's right at 50. Mm-hmm. You think? Hi. You agree? It's 50? Okay. It's 50, according to my daughter and my son. Okay, so we're going back to here.
Go there.
Going back over here.
Yep.
23, we got a stream.
Yep.
Yes?
It's going like a wiggly little snake.
It's a wiggly snake. Okay, it's a stream.
And it's worm. It looks like, and it has A, B, C, D, E, F with dots on the bottom.
Okay, and they want to know what letter is going to have deposition. What letter would you say would have deposition?
A.
Well, A actually would have deposition, but A is not one of the answers because we're looking at something on the inside curve. So A or F, and F is the answer is A. See, even my 6-year-old daughter knows the answer. Mm-hmm. Okay.
If you get it wrong, you can fix it. You can always fix it.
You can't fix it. If you get it wrong, you get it wrong. Okay, anyway. Nice. That's very nice of you to offer that, though. 24. We've got a drumlin. Remember, left behind by glaciers. We just said glaciers have all sizes and shapes of sediment. So it's going to be unsorted sediments.
Yeah.
25. Okay. Yeah. Diagrams show formation of an oxbow lake. And what's going on here?
It looks like there's snakes.
Yeah, you can see the whole bunch of snakes and worms. But on the outside curve, we're getting more and more erosion, and the meander eventually gets cut off because erosion along the outside banks of the meandering stream.
It's like there's 2 snakes, one's curved and one's...
It does. It does look like that. Okay, 26. Oh, see it. Okay. So 26, you see toward which direction is the sand being transported? Well, you see the sand is all here. That means the waves must be going in this direction. So the best answer would be west. I mean, I would say northwest if they had it, but they don't have northwest. So I'm just going to go with west. And west is definitely your answer. 27. Okay, which landscape feature if I'm from glaciers? Okay, well, how many times have I been saying Long Island is a pile of crap left over from the last ice age, right? Not mountains, that's from plate tectonics. We haven't talked about plateaus, so definitely Long Island. 28. We've got parallel scratches, U-shaped valleys, glacier. 29. Stream going 150. Let's move myself over there. Slows down to 100. What is going to get deposited? Okay, so again, that's going to be a reference table question. Oops. All right, so going from 150. Okay, so 150 is kind of in between, well, between 100 and 200. And trying to draw a straight line, sorry. But the only thing 150 centimeter per second stream can carry is pebbles, and not even all of them. So it wouldn't be cobbles or boulders, okay? This is something that would be letting go some of the bigger pebbles, because once we get to 100 would be right there. It's letting go some of the pebbles. Okay, there's the reference table. All right, hold on. Okay, sorry about that. And okay, so going back to this one, we were saying can't hold cobbles and boulders, but would release some of the pebbles. 30, unsorted, rough cobbles, boulders, found at a base of a cliff. What does it sound like? Rough edges, angular edges, bottom of a cliff. That sounds like a landslide, so your best answer is gravity. 31, I've used this exact example. What is that thing right there? That is mushroom rock, right? Mushroom rock. And we get the bottom part is eroded from what agent of erosion? That would be wind. And remember, I can't do the whole rock because wind can only pick up sand so far off the ground. 32, you can see the answer. Velocity of stream decreases. What's going to increase? Well, as the stream speed decreases, then we're going to get an increase in deposition. 33. Okay, so we got a whole bunch of quartz, varying sizes. We dump it into a container. What's it going to look like once we put in the container? And the largest would get deposited first, then the medium, then the small. So it looks like answer 1 right there. You don't even have to go any farther. 34. Okay, so you got wind blowing sand into a big boulder. What's it going to do? It's going to start eroding away and eventually make kind of like a slanted rock appearance. So that would be from wind erosion. And let's see what answers look similar to that. That would look like answer 2, right? Yeah, definitely 2. And let's see, 35. Okay, well, we got 35. Which cross-sectional view shows the general shape of the stream going from A to B? Okay, so A is the outside curve. Faster moving water, that's where the deeper water is going to be, because that's where more erosion towards A. Answer 1 would be a perfectly straight stream, and it's not straight between A and B. I don't know what the heck's going on with 3. So it's either going to be 2 or 4. And like we said, A is the outside curve, faster moving water. Deeper water would be towards A. So that would be, what happened there? There we go. That would be right over there, deeper water.